My name is Eban. I am an assistant professor and extension specialist at the University of Florida in the Agricultural and Biological Engineering Department, and I focus on urban water resources engineering. Circular economy, if you ask probably 10 different people from different industries and different settings, I expect you'd probably get 10 different answers, just slightly different. Everybody kind of has their own take, it seems like. To me, though, what a circular economy means is it simply means kind of closing the loops in our society between the resources that we use to make things and the waste streams, or kind of how we kind of get rid of things and use them. So there are a lot of things that, for example, like we consume and use that follow this model of like it's made, it's produced, we use it, and then once we're done with it, we trash it. And we've had sort of the recycling over the past couple decades that's worked to varying degrees. That kind of does this a little bit, where we're trying to recover this. But the dispose part, this is essentially oftentimes thought of as like a stream of waste, and kind of thinking about this on a broader context, really a broader society. So we typically think of like things of waste having no value. However, it may not be value, for example, to one industry that produced that original product, but that waste stream likely has value to other industries. If you think about the old adage, one man's trash is another man's treasure, that kind of is one way to boil it down. We see that this particularly with like wastewater. So when we have, when we flush the toilet and all the water that comes from our house goes to a wastewater plant in a lot of places. That used to be treated and then discharged into waterways. And over the decades, we found that would kind of impair our water bodies, not create good habitat for fish, maybe lead to algal blooms, things like that. What has started to emerge as a more common way of disposing of that water is treating it and then distributing it through what we call purple pipe, or reclaimed water. And then that's used for like landscape irrigation because it already has a little bit of nutrients in it. And so for lawns and just for agricultural uses even, that water already has a lot of value to it. So instead of just getting rid of it, taking that value, taking that resource that we typically thought of as a waste and bringing it back and using it as a resource. Another way it manifests is kind of through extending the life of products. So you might see it through, this idea of right to repair, basically repairing products, having better maintenance of the products, being able to maintain it and use it for longer so that we're not just disposing and buying a new one and getting it, but being able to upgrade something. So yeah, I think, circular economy essentially is a lot of looking at ways in our society that we can close these loops or link industries that can value what one industry thinks of as a waste stream with one that could see that waste as having value and reusing that rather than just disposing of it. The kind of work that I do focuses on urban water resources, and it's a pretty broad topic. And there's sort of a couple different areas that it kind of overlaps on that we touch on. One is looking at stormwater. So whenever we convert an area that might have been a forest, or let's say a farm, into homes or streets and roads and so forth, we change what happens to rainfall when it falls on that area, and then what happens to that water when it goes into drains or streams, lakes, and ponds. It can carry a lot of pollutants with it. So we look at ways to essentially engineer the landscape and different parts of the development areas to capture that water, treat it or filter it, and remove pollutants from it, and sort of reduce the amount of water also that is going off into our water bodies and might be carrying pollutants with it. So that's one way. We also look at water conservation in the landscape. So for example, in Florida, where it's hot and we do get a lot of rain, we do get a lot of water, but up to half of a home's water use can go just to irrigating the lawn because it's so hot here. And part of that is also due to how soils hold water. So we've found that we can improve the soil quality in one main way by using compost, which is another sort of, it kind of links to the circular economy where we take waste streams, we basically get that we compost, leaves and other organic waste into a usable product. That compost, we incorporate that into the soil, and that improves how much water it holds. And so we can cut down by 25–50% the amount of water that homes are using. And this water would normally be drinking water. It's not just like sort of the reclaimed water, but in many cases where many places it's where we have drinking water that's used for irrigation. And so those are kind of the areas that I typically work on. How can we do basically urban development or the growth of our society and have fewer impacts on our water resources, either from a water supply or just from maintaining the quality of that water through protecting from stormwater runoff. Well, it varies. Today I have about 5 hours of driving ahead of me, but what typically happens, and I'll come back to that in just a moment, what my day typically looks like is I come into the office and have a lot of meetings. So in my job, I have several grad students that work for me who are doing research on various topics. Some of them are looking at, for example, low-cost sensors and how we integrate that into stormwater management and how we look at detecting pollutants in water in urban waterways. And so oftentimes I'll have 2 to 3 meetings with those students just to check in on how they're working, how they're doing. Then I oftentimes, through my position being an extension, which is sort of the way that we translate research into practice, oftentimes I'll work with local professionals or state regulators who deal with these environmental and water resources issues. There's usually a topic that we're working on or trying to advance the way that we do, let's say, stormwater design, or the way that we set the rules for stormwater or for water usage, or how we make recommendations. And so I'll talk with them and have conversations with them. Sometimes we'll have some guidance documents that go out to developers, for example, or be meant for developers. Let's see, so then there's that. And then in my job, there's a lot of writing. So whether it's writing for a publication or reviewing someone else's writing. So a lot of times we are working on research journals, research papers, and trying to get the findings that we have come up with and the recommendations we have out into the public, so that can be applied and used into in those industries. And so usually by the end of the day, I'll probably have 1 or 2 more meetings, which might be with oftentimes undergraduates who might be working in our lab or kind of working on some different projects who have questions. Every once in a while, I get calls from people in the public who have questions about water resources and urban water resources. And it's always, I really enjoy my job because there's a lot of personal interaction. That's maybe something I didn't necessarily expect that I would have as much of, being that I'm in academia or in a research university and so forth. But the type of job that I have, there's a lot of organizations and a lot of entities that work together on different problems and issues. And so being able to communicate, being able to work with them is a big part of this job. The way I actually got into this was this field was that I started out in college looking at doing biomedical engineering. I kind of got into I found my way into that field, or into that major. But we had this intro class that talked about the different sub-disciplines within biological engineering, and we had to give a presentation on it. And I was having a hard time coming up with a presentation on biomedical engineering because it's a new field. And I decided to fake it and do an environmental presentation instead. And that's really how I got interested in this. I found out so much more about this field and working in water resources. And it was, you know, my intentions maybe weren't the best, but the outcome was great and good. I found a local research group that I could start to work with as an undergraduate. We were working in streams and looking at how stream quality changed with urbanization. And then I went and did my master's, and we worked on some stuff called permeable pavement, which allows water to drain through it, which was just, you know, fascinating. And I had a really good opportunity to impact and advance sort of how permeable pavements were used on a scale that I didn't even imagine at the time. I went on to get my PhD and came actually here to the University of Florida and continued looking at the issues that were going on here in Florida, you know, looking at how soil compaction and stormwater management and how soils affect sort of our whole, it really can direct how all of our water resources are managed and of how their availability. So that was, you know, kind of a roundabout answer, but, you know, one of the best pieces of advice that I got when I was in college was from my father, who said, you know, try as many things as you can while you're in college so that you can, you know, really figure out what you like to do and what you want to do. And I think that, you know, though, again, my intentions may not have been the best for this assignment, trying something new and seeing the environmental field and being exposed to that really kind of opened my eyes to how much I enjoyed working with water, working with the environment, working with you know, our natural resources. One of the quotes that I go back to as far as like what motivates me is, or what I find really interesting in my work, is that if there's any magic in this world, surely it's in water. And water is just it's something that we all have to depend on. And if we run out of it, or we don't have good quality enough, we have, it's a big issue. One example that just recently happened that ties back to the circular economy that I had a chance to do was I got interviewed or called up by a local news station here. And one of the things that had happened is that with COVID, a lot of patients are needing to go on oxygen. Well, in the what had happened is that, you know, during the spike in COVID here in Florida, a lot of hospitals were needing to use up a lot of the oxygen that was available and being produced. Well, one of the connections that I wasn't even aware of, that the news station brought to our attention, was that, you know, the water treatment plant who pulls water out of the ground and treats it before it goes out to the community. They use oxygen in the process. They use, you know, liquid oxygen in ozonation as basically a disinfectant, and to try and get organics that might be in the water out of it. But because there was so much of a demand on the hospital side, they actually they put out a request to homeowners to not irrigate their lawns, to reduce the water demand on the water supply, so that because they didn't have enough oxygen, because it was going to the hospital, to be able to continue with their operations at the same water demand that they had been supplying. So I sort of tried to, after I got an understanding of sort of what was happening, you know, I tried to answer some questions and give, you know, provide some context and explain a little bit of how that connection occurs. But that's, you know, it kind of goes back to this circular economy where, you know, we're depending on all of these resources, or we just have this one resource, and then, you know, our economy is kind of set or very sensitive to a shift that we may not even understand the connection to. We're not aware of sort of the linkages, and that kind of a shift can disrupt the economy. If we didn't have necessarily a built-in way to supplement, for example, the ozone or the oxygen not being available for water treatment. So we need to, that's kind of one way with circular economy, to build in redundance, or being able to have different ways to treat the water rather than just being reliant on for example, liquid oxygen. I think in 100 years from now, it's hard to kind of foresee that, but assuming that we don't go down a dystopian path and things go well for us, 100 years from now, teleportation would be really nice. That would be great. But really trying to think of 100 years from now is kind of hard. If we go back, if we maybe take that question the reverse, and I think back to what would people have envisioned 100 years before us? Would they have envisioned this society? It's kind of hard. 1920s, what was going on then? Well, there was no space flight. There was cars were still very basic. They're sort of new thing. Not everybody had them. Computers and microchips weren't even conceived. If you think about, there was this show Star Trek, and that was actually placed like hundreds of years into the future. I think it was like 2200 or 2300, 2400. But some of those things, like a cell phone, was technology essentially that they were using in that TV show. So just even a lot of the things that we dream of or envision that we might think are 100 years off may only be 50 years off. 100 years off might really just be, might be what we conceive would be 200, 300, 400 years from now. It's just the rate of advancements in technology, it's hard to keep up with it. So 100 years in the future, I think that we're going to, some of the things I think will be transformative in our society is understanding and being able to manage the biology, like the microbiome, bacteria and fungi and other microbes in our bodies, as well as in the environment. And that will, I just think that this is going to be integrated into all aspects of our lives, similar to the computer. So, I mean, everybody has a cell phone. Who could have envisioned that the first computer, which took up a gymnasium, would now just, 50, 60 years ago, would, compress down into, be able to fit in our pocket, and they'd be, ubiquitous everywhere. I think it's so hard for us to fathom some of the things that may be happening in our lifetimes even. So there's that, the whole biology side of things, microbiomes, and understanding that, for example, like in agriculture, instead of maybe applying just fertilizers and pesticide chemicals to, control or influence how crops grow and how protected they are from insects and pests, maybe we start applying bacteria colonies or communities or fungi communities. And instead of, and those biology, those microbiomes start actually, harvesting nitrogen from the air to create nitrates and give it to the plants, to where we don't actually interact with, creating that nitrogen or pulling it from the atmosphere and applying it. We just kind of put the right bacteria and the right organisms into the soil. And that would maybe improve soil health in reliable and predictable ways. I think 100 years from now too, one thing I think I'd love to really see us progress on it is, something along the lines of mining our landfills. Going back to this idea of circular economy and, waste streams and seeing those as a resource. How much waste have we kind of sent into these buried landfills because we had not figured out the value that was in that waste stream from another industry and linked those together? I think it would be, a real advancement for us to be able to get to the point to go back into those landfills and recover those resources, even digging through the different types of waste and unpredictable, mixtures that we might find, and be able to process that out and send that to our industries. Because there's a lot of these elements, particularly precious metals, we don't have a whole lot of those available on the earth, and we can't just keep, using them and sending them to the landfill. And then taking that a step further, once those areas are kind of cleaned up, recovered, completely mined, maybe those areas get restored back to having either usable land for society or environmental benefits, to where those functions are restored, in that landscape. I think we're going to have a lot of advancement on sensing, detection, and management of resources. So sensors have come such a long way, particularly on the environmental side, and looking at water resources and detecting even bacteria, and detecting contamination. Something, it could be to where we're able to control these different systems to be able to, like doing wastewater treatment in the sewer line, or maybe it's just actually incorporated into your toilet. And there's maybe a little cartridge that comes out once a month, and that has basically all the nutrients that just maybe it goes off, or you kind of just spread it out in the lawn and that's it. You completely disinfected and composted. I think that we'll also start to think about agriculture and moving agriculture more into the urban area, so that we don't have to do this mass production of agriculture and goods and produce away from the urban center. Vertical farming is a big area of discussion right now, and I can see where the sides of buildings become agricultural real estate, where skyscrapers are now, instead of just renting the office space, they're renting the walls and the outside for farmers to grow crops on. So I think there's a lot of ways that, the future is just exciting in a lot of ways. Just all the things. The real question is, how do all of these things come together, and what linkages are we going to come across and be able to implement into our society? So yeah, wow, lots of possibilities. Possibilities are endless. So thanks for your time, and good luck with your project and with your future cities.